Werewolf Among Us, a multimodal dataset for modeling persuasion behaviors in social deduction games. From as early as childhood, we learn to exhibit persuasive behaviors to influence others during our daily social interactions, such as trying to convince a parent to give us a certain toy. As we grow older, some people, like politicians, utilize persuasion strategies to shape the beliefs of thousands of people. As an essential part of day-to-day social interactions, modeling persuasion is a key building block for developing human-like agents. To this end, we aim to build automated systems for understanding the dynamics of persuasion behaviors in human social interactions and deducing possibly altered belief states as a result of persuasion. In many scenarios, collecting data that includes naturalistic persuasion behaviors is difficult due to privacy concerns. However, social deduction games like One Night Ultimate Werewolf encourage persuasion behaviors and facilitate the capture of rich, naturalistic social interactions in a context where conversations are less likely to include private personal information. Previous works on modeling persuasion in social interactions focus on predicting persuasion strategies from dialogue text alone. However, social interaction is multimodal by nature. Both verbal communication and nonverbal communication are important for analyzing persuasion behaviors. To bridge this gap, we introduced the first multimodal benchmark dataset for modeling persuasive behaviors during social deduction games, comprised of both the transcribed dialogue and the video of groups of participants playing games. Here is a short clip sourced from our dataset of a spirited conversation among a group of participants playing One Night Ultimate Werewolf. The text of the transcribed dialogue is shown as captions. As you can see, both the dialogue itself and nonverbal communication, like gesturing at another player, are important to the conversation.
Villager.
Villager?
Mm-hmm.
What are you? I'm a seer, and I looked in there, and I forgot what the card was. I'm sorry.
Well, I hate to tell you, Chief, but you're not the seer.
Damn.
Ooh.
Yeah, also, if you're going to claim to be the seer, you need to be...
You gotta know what's
Yeah.
If you're in for
Yeah.
a penny, you have to be in for a pound.
Oh, I know.
But that's fine, because you're
Yeah.
a villager now.
Exactly.
Yeah.
Exactly. You know what I'm talking
Mm-hmm.
about.
Wait, what?
No, he's a villager now.
So he was the seer.
Yeah.
No.
But then how do you know he's the seer now?
No, I'm saying he's the villager now.
Oh!
Because these two got swapped.
Okay, troublemaker.
Yep.
Okay.
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 There are multiple prior works on modeling persuasion behaviors in social interactions. This table compares our multimodal dataset with datasets from prior works showing the type of interaction, included modalities, and conversational contexts. The domain of most of these datasets are restricted to online or one-on-one interactions and are all based only on the text modality. Comparatively, we present the first multimodal dataset for modeling persuasion behaviors in social interactions, with our dataset capturing naturalistic face-to-face group discussions in social deduction games. Our dataset is curated from two major sources of videos that capture complete playthroughs of social deduction games. In both sets of videos, the games are played by groups of friends or family members. Our first source is a subset of the publicly released Ego4D social benchmark dataset. This set of videos captures 40 complete games of One Night Ultimate Werewolf and 8 games of the Resistance Avalon. Although the Ego4D dataset features egocentric first-person videos from the perspective of every player, we leverage only the third-person videos from this dataset for transcription and experiments. Our second source is YouTube. We selected publicly accessible YouTube videos that capture third-person videos of 151 completed games of One Night Ultimate Werewolf and similar variants of the game. In all our experiments, we train models on data for only the werewolf games in each subset. We leverage the relatively small set of Avalon games in the Ego4D subset only for evaluating the cross-game domain generalization ability of our models because of the vast differences in structure between the two games. Our dataset includes 3 types of annotations. First, we provide dialogue transcripts of the conversations accompanying each video of a completed game in our dataset. The dialogue is transcribed using an automatic transcription service and is then reviewed and corrected by human annotators. Second, our dataset comes with annotations of identified persuasion strategies for each utterance based on the persuasion taxonomy we have defined here for the conversations in social deduction games. The persuasion strategy taxonomy includes identity declaration, accusation, interrogation, call for action, defense, and evidence. Finally, our dataset includes game-level annotations of the starting role, ending role, and voting outcome for each player. The first modeling task we present for our dataset is the persuasion strategy prediction task. Given the text of a single utterance, we seek to predict the persuasion strategies present in the utterance based on the annotations that use our defined persuasion strategy taxonomy. We also leverage visual features from the input utterance's corresponding video segment to investigate the contribution of the visual modality to strategy prediction. This slide shows examples of our task formulation. We seek to use the text of an utterance spoken during gameplay along with the accompanying video to predict the labeled persuasion strategies. In our experiments, we also study the impact of contextual information on this task by constructing inputs that use preceding utterances as context in addition to the current utterance. In all our models for the persuasion strategy classification task, we use a pre-trained language model like BERT or Roberta as the text encoder backbone and fine-tune it on our dataset. For one set of baseline models, we individually train a binary classification model for each of the persuasion strategies using BERT or Roberta as the backbone. For another baseline model, we use MT-BERT, a multitask model with a shared BERT backbone, which jointly predicts all the persuasion strategies at once. For the base models, the input is only the text of a single current utterance. In base plus C, we build upon the base models by modifying the input to include prior conversational context. The input is the concatenation of the current utterance and the K utterances immediately before it. The consecutive utterances are separated by special tokens to distinguish the context utterances from the current utterance in the input. In base plus V, we include video input along with the text of the utterance. We use a pre-trained video encoder to extract a video feature representation of the video segment corresponding to the input utterance. We then fuse the text encoding of the utterance with the video feature representation before feeding it into the classifier layers of our model. Finally, base plus C plus V is a combination of base plus V, which includes video, and base plus C, which includes context. For this model, we simply compute a weighted linear combination of the probability predictions from the base plus C context model and the base plus V video model. Here, we show the average F1 score over all the persuasion strategies for each of the base models, which operate on the text of the utterance alone. We also show the results of the corresponding base plus C model with context lengths of 1, 3, 5, 7, and 9 previous utterances. We show results for the Ego4D Werewolf and YouTube subsets of our dataset. This ablation study shows how different context lengths affect the performance on the persuasion strategy prediction task. We can see that for each of the 3 base models, incorporating some previous context boosts the performance. However, incorporating too many previous utterances reduces performance, possibly due to the accumulation of too much irrelevant information in the input. We consistently achieve the best performance with a context length of 5 utterances for each of the base models, so for all further experiments with models that include context, we use a context of 5 utterances as the default setting. We also investigate how including video representations in addition to the text can improve persuasion strategy prediction. We show the average F1 score results for each subset of our dataset, with Ego4D on the top and YouTube on the bottom. For each of the 3 base models, we show the performance achieved by the base model in blue, the context model base plus C in orange, the video model base plus V in gray, and the model incorporating both video and context, base plus V plus C, in yellow. We see that for both datasets and all base models, including video and context improves the performance. To investigate the generalization ability of our models across source data domains on the persuasion strategy prediction task, we evaluate our base and base plus C models trained on the larger YouTube subset but tested on Ego4D, both with and without fine-tuning on Ego4D. We observed that for the Bert and Roberta base models, even without fine-tuning on Ego4D, pre-training the models on YouTube results in better test performance on Ego4D than training only on the Ego4D training set, likely due to the much larger amount of training data in the YouTube dataset. These results also suggest that the domain gap between the Ego4D and YouTube videos in the text modality is relatively small, since training on YouTube learns an effective model that can be applied to Ego4D. We also studied the ability of our models to generalize to other social deduction games. Specifically, we show the performance of our models trained on the Werewolf games in Ego4D on the small set of videos in Ego4D where participants are playing the Resistance Avalon, which is another social deduction game. Although the model is still able to perform on the Persuasion strategy classification task, we see a large drop in the average F1 scores. We attribute this to the large domain gap between the game of One Night Ultimate Werewolf and the Resistance Avalon with regard to game rules and winning criteria. We further show the results of experiments with OpenAI's few-shot GPT-3 model on our benchmark under 3 learning settings: 0-shot, 1-shot, and 5-shot. For the GPT-3 prompt templates, we simply use our persuasion strategy definitions and annotation guidelines. Under the 0-shot setting, we include no training examples in the prompt. For the 1 and 5-shot settings, we append 1 or 5 more examples to the prompt respectively. We see that adding more examples boosts the performance further, though GPT-3 still achieves lower performance than the fine-tuned models for our task. Finally, we show how persuasion strategies used in a game can be used to predict the game-level outcome. In this task, we try to predict the voting outcomes for each possible voter-candidate pair of players in the game. In other words, we try to predict whether the voter would vote for the particular candidate at the end of the One Night Ultimate Werewolf game when players vote for one person to die in the game. We use a 26-dimensional input encoding representing the distributions of the persuasion strategies used by the voter and the candidate, as well as the starting game role of the voter as a one-hot encoding. We train and evaluate a simple logistic regression model with weighted binary loss on the One Night Ultimate Werewolf games in the YouTube and Ego4D data subsets. This model achieves an F1 score of 37.2 and AUC of 61.8, significantly outperforming random chance, which achieves an F1 of 28.6 and AUC of 50. This finding suggests that the way the players use persuasion strategies coupled with their roles in the game can be used to predict the ultimate outcome of a social deduction game. To conclude, in this work, we introduced the first persuasion modeling dataset with multiple modalities and rich utterance-level persuasion strategy annotations. We designed computational models that leverage visual and textual representations for understanding persuasion behaviors, and we conduct experiments showing that the visual cues and textual context can benefit model performance on the persuasion strategy prediction task. Our work lays a foundation for future work, like exploring how the audio modality can contribute to persuasion modeling and studying how clip-based models can be used for multimodal representation learning in the social persuasion setting.